This will be Chapter 2. This is page 2-3, Major Components. Although airplanes are designed for a variety of purposes, most of them have some same major components. The overall characteristics are largely determined by the original design objective. Most airplane structures include a fuselage, wings, an empennage, landing gear, and a power point. Fuselage. The fuselage is the central body of an airplane is designed to accommodate the crew, passengers, and cargo. It also provides a structural connection for the wings and tail assembly. Older types of aircraft design utilized an open truss structure constructed of wood, steel, or aluminum tubing. The most popular types of fuselage structures used in today's aircraft are the mono, French for single shell. How do we say this one? Or semi-monocute, monocute, or semi-monocute. These structure types are discussed in more detail under aircraft construction later in the chapter. Wings. The wings are airfoils attached to each side of the fuselage and are the main lifting surfaces that support the airplane in flight. There are numerous wing designs, sizes, and shapes used by various manufacturers. Each fulfills a certain need with respect to the expected performance for the particular airplane. How the wing produces lift is explained in Chapter 4, Aerodynamics of Flight. Wings may be attached to at the top, middle, or lower portion of the fuselage. These designs are referred to as high, mid, and low wing, respectively. The number of wings can also vary. Airplanes with a single set of wings are referred to as monoplanes, while those with two sets are called biplanes. Many high-wing airplanes have external braces, or wing struts, which transmit the flight and landing loads through the struts to the main fuselage structure. Since the wing struts are usually attached approximately halfway out on the wing, this type of wing structure is called semi-cantilever. A few high-wing and most low-wing airplanes have a full cantilever wing designed to carry the loads without external struts. The principal structural parts of the wings are spars, ribs, and stringers. These are reinforced by trusses, I-beams, tubing, and other devices, including the skin. The wing ribs determine the shape and thickness of the wing, the airfoil. In most modern airplanes, the fuel tanks either are an integral part of the wing structure or consist of flexible containers mounted inside the wings. Attached to the rear or trailing edge of the wings are two types of control surfaces referred to as ailerons and flaps. Ailerons extend from about the midpoint of each wing outward towards the tip and move in opposite directions to create aerodynamic forces that cause the airplane to roll. Flaps extend outward from the fuselage to near the midpoint of each wing. The flaps are normally flush with the wing surface during cruising flight. When extended, the flaps move simultaneously downward to increase the lifting force of the wing for takeoffs and landings. Alternate types of wings. 2-5. With the Federal Aviation Administration, the FAA recent addition of the LSA category, light sport aircraft, various methods are employed to control flight and to produce lift. These methods are discussed in Chapter 4, Aerodynamics of Flight, which provides information on effect controls have on lifting surfaces from traditional wings to wings that use both flexing due to billowing and shifting through the change of the aircraft's center of gravity. Handbooks specific to each category of LSA are available for interested pilots. LSAs illustrate various lifting surfaces and control methods. For example, the wing of the weight shift control aircraft is highly swept, and the shifting of weight to provide controlled flight. Alright, so the empennage. The empennage includes the entire tail group and consists of fixed surfaces such as the vertical stabilizer and the horizontal stabilizer. The movable surfaces include the rudder, the elevator, and one or more trim tabs. The rudder is attached to the back of the vertical stabilizer. During flight, it is used to move the airplane's nose to the left and to the right. The elevator, which is attached to the back of the horizontal stabilizer, is used to move the nose of the airplane up and down during flight. Trim tabs are small, movable portions of the trailing edge of the control surfaces. These movable trim tabs, which are controlled from the flight deck, reduce control pressures. Trim tabs may be installed on the ailerons, the rudder, and or the elevator. A second type of empennage design does not require an elevator. Instead, it incorporates a one-piece horizontal stabilizer that pivots from a central hinge point. This type of design is called a stabilator and is moved using the control wheel just as the elevator is moved. For example, when a pilot pulls back on the control wheel, the stabilator pivots so the trailing edge moves up. This increases the aerodynamic tail load and causes the nose of the airplane to move up. Stabilators have an anti-servo tab extending across their trailing edge. The anti-servo tab moves in the same direction as the trailing edge of the stabilator and helps make the stabilator less sensitive. The anti-servo tab also functions as a trim tab to receive control pressures and helps maintain the stabilator in the desired position. We'll hold off right there on page 2-6. All right. See ya.